Hello everyone, here we have one interesting question. For these two cases, when the particle achieves the maximum horizontal range, the initial velocity and the final velocity will be perpendicular to each other. Valid for this case also as well. And the maximum range will have the formula uv by g. I am proving it, just pay attention. For this case, we know the formula of the range was equal to u square sine 2 theta by g. If we want the maximum value of the range, then this term should become maximum. You remember that maximum value of sine 2 theta can be 1. So the Rmax comes out to be u square by g. And for that, theta is equal to 45 degree. I hope you remember. 2 into 45 degree will become 90 degree, sine 90 degree will become 1. It means this angle of projection is 45 degree and this angle is also 45 degree. And you get the idea that u and v will be perpendicular to each other. How? If we draw the horizontal line and we draw the u, it is 45 degree above the horizontal line. Okay, u vector will be directed like this, and if we draw the v vector, it will be 45 degree below the horizontal line like this if you extend. So if I draw the v vector like this angle is 45 degree. It gives you the idea, if you wish to write the things in the vector form, that u vector is perpendicular to v vector. Whenever the particle attains the maximum horizontal range, in this case, the u vector and v vector will be perpendicular. If this angle is theta, then this angle will be 90 degree minus theta. Okay. Same thing we have to do for the second case. So let's pay attention. For this case, we can write one thing vectorially. T is equal to 0. We have projected it. T is equal to capital T, it is hitting the surface. Okay, so v vector is equal to u vector plus g vector. I hope you agree with this. I am making the triangle using these vectors. Using the triangle law of vector addition, we should be making the v vector like this. Now, with respect to the horizontal, we already know that u vector is making an angle theta. Okay. This angle is 90 degree. This angle is 90 degree minus theta. Suppose we wish to write the area of this triangle. What we should be writing? Area of this triangle. Area of the triangle is half base into height. Suppose I consider the base length as gt. So half gt and height. Height will be this dotted black line. And this length will be u cos theta. I hope you understand, u cos theta. Okay. Now we have one interesting data visible here. Focus on this t and u cos theta. What you get from this computation? Horizontal speed u cos theta into the total time of flight t. U cos theta into t. I hope you remember, this gives us the range. It means the area is equal to g by 2 multiplied with range. I hope you agree with it. Fine. Now suppose we want to maximize the range. If we want to maximize the range, then area of this triangle should be maximum. That's the brilliant concept. I repeat, if we want to maximize the range, the area of this triangle should be maximum. I'm writing this. For R to be maximum, the A should also be maximum. Okay, now it's an optimization problem. We have to do something so that area of this triangle becomes maximum. For that, pay attention here. We already know the U, and V can be obtained using the conservation of the mechanical energy, as we have neglected the air resistance. K initial plus U initial is equal to K final plus U final. Here we imagine the U to be 0 on the surface. Initial kinetic energy is half m U square. Initial potential energy is mgh. Final kinetic energy is half m V square, and final potential energy is 0. Okay. In this case, we'll get V is equal to root of U square plus 2gh. That's how we derive it. Done. Now, in this triangle, we have one constraint. The length of U vector is fixed as well as the length of V vector is fixed. We can change the angle as per our convenience for obtaining the Rmax, but the length of V vector and U vector has been fixed. What I mean to say, mod of U vector is constant as well as the mod of V vector is also constant. Okay. Now we have to maximize the area of some triangle, and the two sides of the triangle, their length has been fixed. What should be the angle between these two sides, the red and the blue, so that area of triangle becomes maximum? Can you report the answer in the comment box? We need the maximum area of this triangle. What should be the angle between U vector and V vector? Okay, I'll give you the hint. Suppose you consider some vector having fixed length. Let's say its length is 3. Another vector has length 4, and that vector I place like this. Using these two vectors, I need to obtain the maximum area of the triangle. So I can construct a triangle like this. Another case, I take the vector of length 3 here. I take the vector of length 4 here. And then we try to construct the triangle. We'll get some area. I take the vector 3 here and I take the vector 4 here. Then we take up some area. In which case will be getting the maximum area if the length of the two sides of the triangle is fixed and we need the maximum area of the triangle. You can draw other cases also if you wish. Let's say you take 3 here and then you take 4 here on this side. How much is the area of triangle? You can see it yourself. We'll be getting the maximum area of the triangle when these two sides are perpendicular. Okay, it's a nice concept. If the two sides of the triangle have the fixed length and we want the maximum area of the triangle, these two sides must be perpendicular to each other. Done? So, if this was theta, this angle should be what? 90 degree minus theta, and then this angle must be theta. Okay, that's what I have written here. If this angle is theta, then this angle is 90 minus theta. With the horizontal line, the red vector is making angle theta like this. With the horizontal line, the red vector making angle theta like this. With the horizontal line, the V vector is making angle 90 minus theta like this, which we can see. The V vector will be making an angle 90 degree minus theta like this. Now, let us try to obtain the maximum area of this triangle. The Amax, we know that will be equal to G by 2 of Rmax. And now can you tell what is the maximum area of this triangle? Such as if I ask you what is the maximum area of this triangle, what will be your reply? Half into base into height. So same you can do here, half into base into height. Amax will be half UV is equal to G by 2 R max. The 2 gets cancelled out, and here we obtain an interesting expression that R max is equal to UV by G. Got it? Pretty important result. I hope you liked the derivation, and it can be a handy tool in numerous questions, such as if someone gives you this particle is projected making an angle 30 degree with the horizontal and it achieves the maximum range along the horizontal, then what should be this angle? Now you can answer it direct. If this angle is theta, this should be 90 degree minus theta, which will lead us to 60 degree. Got it? So in many questions, you can use these tricks. I hope you liked the video. If you want more such videos, let me know in the comment box. Stay awesome. See you again.